Today we are discussing about the module 4, continuation of the previous session, that is Legendre's polynomials. Even in this there are some problems in your model question paper. Whenever the problem comes, I will tell you this is the basics of Legendre polynomials. So this no need of by hearting this, but you should know the values. You can find it out later, just know it. Okay, write and practice, then only you will master it, otherwise you can't mug it up. If we choose an is equal to Legendre polynomials, if we choose an is equal to 1 into 3 into 5 till 2n minus 1 divided by n factorial. If we choose an equal to 1 into 3 into 5 etc. till 2n minus 1 divided by n factorial, then Pn of x is equal to 1 into 3 into 5 till 2n minus 1 divided by n factorial into x power n minus n into n minus 1 into n into n minus 1 divided by 2 into 2n minus 1 into x power n minus, to see how it goes. Then n into n minus 1 into n minus 2 into n minus 3 divided by 2 into 4 into 2n minus 1 2n minus 3 x power n minus 4 plus minus here minus again. This derivation is not there for you. This is called as the standard form of the Legendre's polynomial. Derivation is there, but in your syllabus it is not there. Exam they will not ask that. So derivation of Legendre polynomial is not there. So only the problems in Legendre polynomial. See, now we once we know the standard form of Legendre polynomial, we first write the few Legendre polynomials. We first try to write the few Legendre polynomials by putting here n equals 0, 1, 2, 3, 4. By substituting there, n equals 0, 1, 2, 3, 4. Okay. By substituting n equals 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Like. So what happens here when we take p naught of x? When we take p naught of x, n0 p naught of x, here the first term will be there. n0 means 2 minus 1, 1. 1 factorial is 1, so 1. And n0, x power 0, 1. This no need. X power 0, 1. Here x power 0 minus negative. We need not take negative. X power 0, 1. So 1 into 1, we get p naught of x is equal to 1. Remember this. This is the standard thing which you have to know. P naught of x, Legendre polynomial, when n equals 0, p naught of x is always equal to 1. Okay. Now we will see what will be p1 of x. P1 of x, it will be, see here, 2 into 1, 2 minus 1, 1. Okay. Here when 0, okay, 0 p naught of x is 1, because 0 factorial is 1 and x power 0 is 1. Yeah, that way. Okay. P naught of x is standard, it is 1. P1 of x, put n equals 1. So 2 into 1, 2, 2 minus 1, that is 1. Divided by 1 factorial 1. Then here x power 1, 1. Then here x power 1 minus 2. X power 1 minus 2, x power minus 1. So negative you can neglect. So x power 1 is x. So 1 by 1 factorial into x. So p1 of x is x. So remember this. P naught of x is 1. P1 of x is x. Then P2 of x. P2 of x means n equals 2. P2 of x means n equals 2. 2 into 2, 4. 4 minus 1, 3. So 1 into 3. Till 3 it will come. 2 into 2, 4. When n equals 2, 2 into 2, 4. 4 minus 1, 3. So 1 into 3 divided by 2 factorial. Whatever it 1 into 3 divided by 2 factorial into x power 2. So x power 2. Here when I substitute it as 2. N 2 into 1 divided by 2 into 3. So 2 into 2 minus 1 divided by 2 into 3. And then n is 2. X power 2 minus 2 0. Okay. 2 power 0. Yeah, sorry, x power 0. X power 0. Okay, the next term if you use it will be x power 2 minus 1 negative. So we stop here only till here. So we get like this. P2 of x is 1 into 3 by 2 factorial x squared, this one. How we got it? How I got it from this formula by substituting. Okay. So this will be now 3 by 2 x squared. 2 into 2 minus 1 is 1. 2 cancels. So 1 by 3. So 3 by 2 into x squared minus 1 by 3. 3 by 2 into x squared minus 1 by 3. That can be written as, I wrote this 1 by 2 outside and this 3 I multiplied inside. So 3x squared minus 1. So 1 by 2 into 3x squared minus 1. Okay. Now similarly going to P3 of x. P3 of x means n equals 3. Same here, n equals 3. So what happens here? N equals 3 means 3 into 2, 6, 6 minus 1, 5. So till 5, 1 into 3 into 5 divided by 3 factorial, x power 3, and x power 3 minus 2, that is x power 1, so possible. So 3 into 2, 2 into 3 into 2, 6 minus 1, 5. So 3 into 2 divided by 2 into 5, x power 1. Here 3 minus 4, 3 minus 1, so we can neglect. So that way we are getting it here. 1 into 3 into 5 divided by 3 factorial. From the formula above I explained. X cubed minus 3 into 2 divided by 2 into 5 into x. Okay. Now here what happens is 3 get cancelled. So 5 by 2 I removed outside. 5 by 2. So 5. 3 factorial means 3 cancels. 3 into 2 into 1. So 2 will be there. So 5 by 2. X cubed minus 2 cancel. 3 by 5 x. So here I multiplied 5 is just to write in some standard form, as in all the books is in the same standard form. So 1 by 2, 5x cubed minus 3x. Even this is correct, but write in the standard form, it's written as 1 by 2, 5x cubed minus 3x. That is P3 of x. Similarly, when you find P4 of x. So P4 of x, when you substitute here, see, P4 of x means 2 into 4, 8, 8 minus 1, 7. So 1 into 3 into 5 into 7 divided by 4 factorial. Here x power 4, substitute all that. Here 4 minus 4, 0. So till this term, and put all n equals 4. So all the terms are possible. So we'll get 1 into 3 into 5 into 7. Take the pencil and just check it. Divide by 4 factorial into x power 4 minus 4 into 3 by 2 into 7 into x squared plus 4 into 3, that is here. 4 into 3 into 2 into 1 divided by 2 into 4, 4 into 8 minus 1, 7, 2 into 4 into 7, 4 into 8, 8 minus 3. So 4 into 2, 8, 8 minus 1, 7. Then 4 into 2, 8, 8 minus 3, 5. Same thing, 2 into 4 into 7 into 5. Then here x power 4 minus 4, x power 0 is 1. So you get like this. So if you multiply this, here 4 factor in that 3 get cancelled. So 4 into 3 into 2. So 3 get cancels. 4 into 8, 7 into 5, 35 by 8. X power 4. This also simplified to 2 times. 6 by 7 x squared. This also 2 cancels. 4 cancels. So 3 by 35. Okay. So total it will be 1 by 8 I kept outside. 35 I multiplied inside. 1 by 8. 35 x power 4 minus 30 x squared plus 3. This is P4 of x. Now, okay, now we found out by using the Legendre polynomial formula, we found out P0 of x, P1 of x, P2 of x, P3 of x, and P4 of x. We found out P0 of x, P1 of x, P2 of x, P3 of x, and P4 of x. Okay, now you can check, to verify Legendre's, to verify whether you are correct or not. To verify whether you are correct or not, there is a method. When you put x equals 1 in the definition of the Legendre polynomial, by the definition of the Legendre polynomial, if you put x equals 1 in P0 of x or P1 of x or P2 of x or P3 of x or P4 of x, you should get 1. By the definition of Legendre polynomial, in all the expressions you got till now, that is P0 of x, P1 of x, P2 of x, P3 of x, P4 of x, if you put x equals 1, we should get 1. Then only it will be a Legendre polynomial. We'll check it. Okay, P0 of x is already 1. So when you put x equals 1, see x equals 1. Here when you put x equals 1, 3 minus 1 to 2 by 2, 1. Here when I put x equals 1, 5 minus 3, 2 by 2, 1. Here when I put x equals 1, 35 minus 30, that is 5. 5 plus 3, 8. 8 by 8 is 1. So all the terms, the expressions, that is P0 of x, P1 of x, P2 of x, and P3 of x, till now you got it as when you had put x equals 1, you will get it as 1. The value is equal to 1. So clearly all these expressions give 1 at x equals 1. That is the definition of Legendre's polynomial. That is actually the definition of Legendre's polynomial. Okay, that is the definition of Legendre's polynomial. Clear? Now, if we go further, that is one more formula. Again, derivation is not there for this, but the problems are useful. Model question paper problems are there. It's called Rodrigues formula. Rodrigues formula. So this is a formula for the Legendre polynomial Pn of x. This is the formula for the Legendre polynomial Pn of x. Okay. Formula for the Legendre polynomial Pn of x in the form. It is in the form Pn of x is equal to 1 by 2 power n into n factorial d power n by di, that is nth derivative, d power n by dx power n, x squared minus 1 power n. This is known as Rodrigues formula. So Rodrigues formula, this is a formula for the Legendre polynomial. So Rodrigues formula, this is a formula for the Legendre's polynomial Pn of x. Means Rodrigues formula is another formula from which you can find Legendre polynomial. We'll see that. This type of questions will come in the exam. So what is that Rodrigues formula? Pn of x is equal to 1 by 2 power n into n factorial, nth derivative dn by dx power n, x squared minus 1 power n is known as Rodrigues formula. Okay. This is known as Rodrigues formula, and for this derivation is not necessary. In the exam they will not ask for it, so not derived. Now, using Rodrigues formula, obtain the expressions for P0 of x, P1 of x, P2 of x, P3 of x, P4 of x, and P5 of x. Hence, express x squared, x cubed, x power 4, x power 5 in terms of Legendre polynomial. This is the question. See, use Rodrigues formula. That is the formula which I just now gave above. Pn of x formula, Rodrigues formula. Use Rodrigues formula to obtain the expressions for to find out P0 of x, P1 of x, P2 of x, P3 of x, P4 of x, and P5 of x. Hence express the next part of the question is hence express x power 2, x power 3, x power 4, x power 5 in terms of Legendre polynomials. Okay. Now what we do, first we write down the Rodrigues formula, that is Pn of x is equal to, first we write down the Rodrigues formula. Pn of x is equal to 1 by 2 power n into n factorial, nth derivative dn by dx power n, x squared minus 1 power n. Again I repeat, we have the Rodrigues formula. Pn of x is equal to 1 by 2 power n factorial, nth derivative of x squared minus 1 power n, dn by dx power n of x squared minus 1 power n. Now here you have, see how to find out the formula. See, first if I want to find P0 of x, you know from the starting I derived P0 of x is 1, P1 of x is x. We'll see whether we get it. See, P0 of x means put n equals 0. If I put n equals 0, 1 by 2 power 0, 0 factorial, d0 by dx power 0, x squared minus 1 power 0. Okay, this will be now anything power 0 is 1. Here 1, 2 power 0 is 1, 0 factorial is 1, so it is equal to 1. Very simple. When I substitute here n equals 0, 1 by 2 power 0 into 0 factorial, nth derivative means n 0. We have to put n equals 0 now. So x squared minus 1 power 0. Any number power 0 or x squared minus 1 power 0 is 1. This derivative of 0 means no need of derivative, so it is 1. Then here 1 by 0 into 0 factorial also equal to 1. 1 by 0, 0 factorial 1, so 1. So P0 of x equal to 1. Now P1 of x. So P1 of x is equal to 1 by 2 power 1 into 1 factorial d by dx of x squared minus 1. d by dx of x squared minus 1. P1 of x. Okay. So 1 by 2 power 1 into 1 factorial d by dx of x squared minus 1. So here we understood why, because here substitute here P1 of x, put n equals 1. Then P1 of x equals 1 by 2 power 1 into 1 factorial d by dx, n is 1, x squared minus 1. So differentiation of x squared is 2x. Here 1 by 2 cancel x. So P1 of x is x. So it's same thing what we got from the Legendre's polynomial. Then, so remember these two, P0 of x is 1 and P1 of x is x. Now P2 of x. P2 of x means 1 by 2 power 2 into 2 factorial. Second derivative d squared by dx squared, x squared minus 1 power 2. So from the Rodrigues formula you get like this. 1 by 2 squared, that is 4. 1 by 4 into 2, that is 1 by 8. 1 by 8, we are getting 1 by 8. Then second derivative, x power 4 minus 2x squared plus 1. So first derivative will be x power 4 is 4x cubed. The next derivative of 4x cubed, that is a 12x squared. 3x squared into 4, that is 12x squared. Okay, 12x squared minus here again 2 times derivative. Again 2 times derivative. 2x into 2, that is 4x. Differentiation again, that is 4. Differentiation of constant is 0. So you know how to derive 2 times with respect to x, simple things. So 1 by 8 into this. So what I do here, I remove 4 outside. If I remove 4 outside, 4 2 times 8, so 3x squared minus 1. So P2 of x is 1 by 2 3x squared minus 1. Again the same formula what you have derived. 1 by 2 P2 of x is equal to 1 by 2 into 3x squared minus 1. Okay. Now P3 of x. If I go for P3 of x, 1 by 2 power 3 into 3 factorial, 3 times derivative x squared minus 1 power n. Okay. Now 1 by 2 into 2 into 2, that is 8. 3 factorial is 6. 8 into 6 is 48. Third derivative d cubed by dx cubed. This x squared minus 1 power 3, you can either expand by binomial expansion formula, or you can expand by ordinary a minus b whole cubed formula, that is a cubed minus b cubed minus 3ab into a minus b. You get like this. There's no in elementary 8th, 9th you have studied how to expand it. If it is too high, that is 4, 5, power 4, 5, then you the good suggestion is no need of using formula, use binomial theorem. I'll tell you when you come to the next. So here differentiate 3 times. First it will be 6x cubed, then it will be 18x squared. Then so first it will be, if you differentiate once, it will be 6x power 5. Then second derivative will be 6x power 5. Second derivative will be 30x power 4. So next derivative, third, 120x cubed. Similarly here we get minus 7x. This will be, the two terms will be 0. So here 24 I'll remove outside. 24 will be common in both of this. So when I remove 24 outside, inside will be left with 5x cubed minus 3x. So outside 24 by 48. So it is P3 of x is 1 by 2. P3 of x is 1 by 2. Px cubed minus 3x. P3 of x is 1 by 2. 5x cubed minus 3x. This also tallies with the old Legendre's polynomial. What we studied, P0 of x, P1 of x, P2 of x, P3 of the same thing we are getting. Now comes P4 of x. So x squared minus 1 power 4 means you can do one thing, x squared minus 1 square, or you can use binomial theorem. So now P4 of x. P4 of x using here 1 by 2 power 4 into 4 factorial. D4 by fourth derivative, x squared minus 1 power 4. Okay, now what a 2 power 4 is 16, 4 factorial, 4 into 3 into 2, that is 24. Fourth derivative of x squared minus 1 power 4, I use this. X is x squared, a is 1 and n is 4. So x power n, x squared power 4, that is x power 8, minus nc1, that is 4c1, 4c1 is 4, x power n minus 1, x power n minus 1. So x squared power, x is x squared here. Compare, you know binomial theorem, x squared power, what it will be? X squared power n is how much? 4 minus 1. 4 minus 1 is 3. So x squared into 3 will be x power 6. So like that, nc2, 4c2, x squared power 4 minus 2 into a squared. The a is 1. Like that, 1 squared is 1, like that. Goes on till you get 4 means there should be 5 terms. 1, 2, 3, 4, 5. Power 4 means there should be 5 terms. So from binomial theorem you can expand it. Then even there is from the nth derivative there is a formula. Otherwise you have to differentiate 4 times. It will take a lot of time. So use this formula. Nth derivative of x power m is equal to m factorial divided by m minus n factorial into x power m minus n, where m is greater than n. So it is m factorial divided by m minus n factorial x power m minus n, where m is greater than n, nth derivative of x power m. So P4 of x will be 16 by 24. If you take this nth derivative, n is 4, m is 8. So 8 factorial divided by 8 minus 4, 4 factorial, x power 8 minus 4, x power 4. Similarly 4, x power 6 and nth derivative n is 4. So 6 minus 6 factorial m factorial divided by 6 minus 4, 2 factorial, x power 6 minus 4, 2. Similarly, minus 4, that's our minus 4, then plus 6, 4, 4. So x power 4, that's 4 factorial divided by 4 minus 4, 0 factorial. X power 4 minus 4, 0 factorial. So this is the last. Next will be negative term. So we get here 1 by 16 in 24, all of this calculate it. And then simple things, you remove 48 common outside. Then we get P4 of x is equal to 1 by 8 into 35x power 4 minus 3x squared plus 3. Okay, this is the same as what you got in the beginning. Similarly, P5 of x, same way by using this formula, P5 of x, using the formula here, what you get, P5 of x equal to this formula, Rodrigues formula, P5 of x is equal to 1 by 2 power n, 1 by 2 power 5 into 5 factorial d, fifth derivative of x squared minus 1 power 5. So here now, 1 by 32 into 120, fifth derivative. This again expanded by binomial theorem. Binomial theorem I have given here. You have used it. So x squared minus 1 means x is x squared and a is 1. X is x squared and a is 1. There will be 6 terms because n is 5. There will be 6 terms. A lot of expansion you have done in your PUC. So then the nth derivative, this formula we are using to find the nth derivative of x power m factorial divided by m minus n factorial x power m minus n. So 10 factorial divided by 10 minus 5, 5 factorial x power 10 minus 5. Minus 5 here, 8 factorial m factorial divided by 8 minus 5, 3 factorial x power 8 minus 5, that is 3, plus 10 into m factorial 6 factorial divided by 6 minus 5, 1 factorial into x power m minus n, 6 minus 5, 1. So next if we take this one, 4 factor, 4 minus 5, you are getting negative. So we stop here. Expanding all of this, ordinary calculation, you can use your calculator, you will get like this. And then finally 1 by 8, standard form you have tried, 63x power 5 minus 70x cubed plus 15x. 63x power 5 minus 70x cubed plus 15x. Now the next part of the question, that is to express hence express x squared x power 3 x power 4 x power 5 in terms of Legendre polynomials. Okay, so here we now express x squared x power 3 x power 4 x power 5 in terms of Legendre polynomial. So consider P2 of x. How to x squared? We start, so P2 of x has got the term x squared. So P2 of x is half into 3x squared minus 1. So 2 into P2 of x is 3x squared minus 1. So write 3x squared is 1 plus 2 P2 of x. But you know P naught of x is 1. We have to express in terms of Legendre polynomial. You know that P naught of x is 1. So divide by 3. So 1 by 3, 1 is written as P naught of x plus 2 by 3 P2 of x. So x squared is written in terms of Legendre polynomials. I hope write and study. Any doubt you can ask later. Okay. So consider now you want x cubed. So P3 of x. P3 of x is equal to half into 5x cubed minus 3x. So half into 5x cubed minus 3x. So I bring 5x cubed to one side, remaining to the other side. So 5x cubed equals 2 into P3 of x plus 3x. And here you know P1 of x is x. So in place of x, I can write P1 of x. In place of x, I can write P1 of x. And so here x cubed equals 2 by 5. 2 by 5 P3 of x from here, 2 by 5 P3 of x plus 3 by 5 phi1 of x. So x cubed expressed in terms of Legendre polynomials. Now for x power 4 we take P4 of x. For x power 4 we take P4 of x. P4 of x is 1 by 8 into 35x power 4 minus 30x squared plus 3. So 8 into P4 of x is this. So I want x power 4. So I bring it to one side, remaining to the other side. So 35x power 4 equals this one. So x power 4 is 8 P power 4 of x plus 30 into x squared. X squared can be written as here. X squared can be written as 1 by 3 P naught of x plus 2 by 3 P2 of x. So here x squared. So 10 into 3. So 2 by 3. 2 by 3, that 3 get cancelled. So P2 of x squared is, what is the value? 2 by 3 P2 of x. So 1 by 3 P naught of x is 1. That 3 get cancelled. 3 get cancelled here. I hope you followed. Put the x squared value, that's all. put this x squared value, here. So we get like this, minus 3. Now we get here 35x power 4, 8p power 4x plus 20p of x plus 10 plus 10 minus 3, that is 7. So here 8 by 35 p4 of x plus 20 by 35 means 4 by 7 p2 of x. 7 by 35 is 1 by 5. 1 is 7 into 1. 1 is nothing but p naught of x. Okay, similarly now p5 of x. So we want to express x power 5 in terms of Legendre polynomials. So to get x power 5, we take p5 of x. And p5 of x we know before we have derived 1 by 8, 63x power 5 minus 70x cubed plus 15x. So bring cross multiply 8 p5 of x is 63x power 5 minus 70x cubed plus 15x. So 63 we want x power 5, 63x power 5 is so much. So 63x power 5 is equal to 8 into p5 of x plus we put the x cubed value. See, x cubed value is there here. This value substitute here. You will get this value substitute here. See, that is x cubed. In place of x cubed, I substitute this. Minus 15x is taken as p1 of x. Then simplify everything. I hope you have followed. 70 means 5. So 5x cubed. 5x cubed means if you take 5 and 5 get cancelled. So 2p3 of x plus 3p1 of x. 2p3 of x plus 3p1 of x minus 15 into x is p1 of x. So using x is equal to p1 of x. Very simple. Simplify all of this. So x power 5 is equal to 8 by 63 p5 of x plus the 28 p3 of x, that is 28 by 63, 4 by 9 p3 of x plus 27 by 63, that is 3 by 7 p1 of x. So now we have studied x1, x2, x3, x4, how to express it in terms of the polynomials. So once again I repeat here, see, when you want to express p5 of x in terms of Legendre polynomials, you take p5 of x. When you want to express x power 4 in terms of Legendre polynomial, take p4 of x, like that. Now what happens here? I want to express x power 5, that I want to write x power 5 equal to in terms of polynomials. So what we do, we cross multiply. It's simple, you understood. Next, same way other things also. Next I bring the term containing x power 5 to one side, remaining to the other side. So I get 63x power 5 equals 8p5 of x plus 70x cubed minus 15x. Now already we have found out the coefficient of x, x squared, x cubed, x power 4, etc. We'll substitute that. So x cubed is here, see, this value will substitute here. This value will substitute here. X cubed, 70x cubed there, here we'll substitute, here we'll substitute. So when you substitute, it is 2 by 5, 3 by 5, 5 is common outside, 14 times 70, so 14 minus 15x, and x is p1 of x. So everything is written in terms of the polynomial. So 63x power 5 is equal to 8p5 of x plus 28p3 of x, okay, plus 28p3 of x plus 27p1 of x. So further still we can simplify. X power 5 equals 8 by 63, cross multiplying by 63 each term, p5 of x plus 28 by 63, 4 by 9 p3 of x, 27 by 63, 3 by 7 p1 of x. So in this way we expressed x power 5 also in terms of the polynomial. So here today what we studied is very important, because next session, tomorrow onwards, we will solve problems in model question paper. The problems, very easy it is. Write down the notes, write it again and again, write and study, otherwise you'll never do it. So write and study. Any doubts you get, please tick it. You can ask me when you come to the college, or you can call me and ask me, or through message if possible. So don't be frightened, don't hesitate, write and study. And also once again I request you, write the notes. I'll check it, and also assignment 1, solve it. Now to summarize, because we are nearly in the end of the session. So to summarize here, today we discussed the concept of module 4, that is Legendre polynomial, the general Legendre polynomial, only the statement. And from that we found out p0 of x, p1 of x, p3 of x, p4 of x. But you know p0 of x is 1 and p1 of x is x standard. Then p3 of x, P2 of x, P3 of x. P2 of x contains terms x squared, P3 of x contains x cubed, P4 of x contains x power 4, P5 of x contains x power other terms. General standard form is there. I have told you how to do it. Then comes the Rodrigues formula, only the statement. From this Rodrigues formula, question will come sometimes. From Rodrigues formula, find P0 of x, P1 of x, P2 of x, P3 of x, P4 of x, and P5 of x. It's very simple. I have given the binomial theorem also how to do it, and also the nth derivative of x power m also. I use that. It will be simple. After you have found out P0 of x, P1 of x, P2 of x, P3 of x, P4 of x, and P5 of x, then the question sometimes come express x power 2, x power 3, x power 4, x power 5 in terms of Legendre polynomials. So for example, if you want x squared, take P2 of x. Bring x squared to one side, remaining to the other side. Wherever possible, substitute the value of x. 1 means P0 of x, x means P1 of x, like that, and simplify. And finally, for example, you can see here, x power 5 is expressed in terms of Legendre polynomials. It should be like this: 8 by 63 P5 of x plus 4 by 9 P3 of x plus 3 by 7 P1 of x, like this. So I wind up the session. All the best. Thank you.